Greetings, AP Chemistry students. In this video, I want to go through this titration curve analysis worksheet and kind of show you how I would answer and approach these problems. So, on this first curve, since we're starting at a low pH of around 1, and then the pH stays very low, and then it shoots up to a very, very high pH. And it doesn't appear that we form an initial buffer here or anything. It looks like what's in solution is a strong acid and our titrant is a strong base. The equivalence point looks like it happens right there at a pH of 7. That's another clue that this is a strong acid, strong base titration. And so the equivalence point occurs at what appears to be 18 milliliters. Now, since this is a strong acid, strong base titration, pKa's and pKb's are not applicable. Now, if we're trying to determine the concentration of the sample, we're going to use the MAVA equals MBVB. And we're going to say that the sample being titrated to find that molarity of the acid is going to equal the molarity of the base, which is zero point 0.1. And then we used 18 milliliters. And we're going to divide that by 10 milliliters of the sample. So we do zero point 0.1 times 18 over 10. We find that it equals 0.18 molar. And this next one, the pH starts a little bit higher. There's this little curve where we're forming a buffer initially. The equivalence point appears to be at a pH of around 8. So this would imply that it is a weak acid. And the thing we are titrating it with, since the pH ends up going up quite high, strong base titration. Equivalence point looks like it once again occurs at 18 milliliters. The pKa, so we need to trace over to half of 18, which is 9, and see if we can find what the pH there is. It looks like it's around, I don't know, 4.6 or 4.7 would be the pKa. Kind of guessing there. And then the answer to this problem is going to be exactly the same as the first one because the volume was identical. So once again, looks like it's 0.18 molar solution. It took the same amount of volume of base to titrate it. And we were working with the same volume of acid and the same molarity of base. Also, in case you have forgotten, we were using 10 milliliter samples of the acid in the titration labs that y'all did in class as well. Now, this one, we're very clearly starting with a base. And so now we got to figure out what's the pH around the equivalence point. It looks like it's around 7. This looks like this is going to be a strong base, strong acid titration. The equivalence point here looks like it occurs at around, I don't know, 20 or 21. I'm going to call it 21 milliliters. Call it what you want. pKa or pKb is not applicable. And then if we use MAVA equals MBVB, then the molarity of the base equals the molarity of the acid, which is going to be, in this case, says the titrant is 0.1 molar. We used 21 milliliters. We divide it by 10, and we're going to come up with 0.21 molar for our base. This next one, in this case, it looks like our equivalence point occurs at a pH of around 5.5 or so. So this is clearly not a strong acid, strong base. Also, we can see that there appears to be some buffer formation at the beginning. So this looks like we're starting with a weak base, but using a strong acid because the pH ends up quite low at the end. Titration. The equivalence point appears to be at around 16 milliliters. Uh, for this one, we need to go halfway to the equivalence point, which is going to be at 8. The pH there looks like it's around, oh, what is that, like 9.1? That would mean that the pKa of our weak acid is 9.1. So we take 14 minus 9.1, we would get that the pKb, which is what's relevant to our base, is 4.9. Once again, if we find this, if we find the pH at halfway to the equivalence point, the pH equals the pKa. But since we're talking about a weak base, we need to find its pKb because it's a base. And so we subtract it from 14. Then to determine the molarity of the base, um, what is happening here? Molarity of the base is going to equal the molarity of the acid, which is 0.10, times the volume of the acid that we used, which is 16, divided by the volume of the base, which is 10 milliliters, which gives us 0.16 molar for our base. This one right here is clearly a polyprotic acid. I'm going to guess that since our pH starts around 3, it's weak. So we're analyzing a weak polyprotic acid with a strong base that we're adding to it. So when we try to find the equivalence points, the first one looks like it occurs right here, which is going to be at 16 milliliters. And the second equivalence point looks like it's right here, which is going to be at, that's about 35 milliliters. This is one of those cases where sometimes these things don't work out in real life how they should. There could be some errors with the measurements, or the graph could be wrong, or the pH meter could be miscalibrated. But these should have been spaced at, like, if the first one's at 16, the second one should be at 32, not at 35. But to find the pKa1, be halfway to the first equivalence point, so we go to 8 milliliters, and that looks like that's going to be a little higher than 3, so we'll call that like 3.1. And the pKa2 would be, well, let's just pick halfway in between 16 and 35. That's going to put us somewhere around 26. So it looks like the second pK is about 6.5. Now to find the concentration of the acid, we just need to base all of this on the first equivalence point. So the molarity of the acid is going to equal the molarity of the base, which is 0.1 molar. We used 16 milliliters divided by 10 milliliters of the acid. And so the molarity of the base would be 0.16. And now for the last one. This is, the pH starts fairly low and it ends fairly low, although our equivalence point occurs somewhere close to 7. But this is a weak base, weak acid titration. You'll almost certainly not really be asked about these on the AP exam because doing the actual calculations with them is a nightmare. Um, if we're trying to like figure out what's happening along here, but because you have, they're not conjugates of each other that you're adding. Otherwise, you'd just be making a buffer. It looks like the equivalence point occurs somewhere around. Uh, I don't know where we want to call it. We can call that 9 milliliters if we want to. Uh, we could look at this and go at 4.5 to try to figure out what the pKa is. Well, the pKa looks like it's going to be around 9.3. So the pKb would be 4.7. And then the molarity of the base would equal the molarity of the acid, which it says we assume is 0.10, times we're using 9 milliliters of it, because that's what it was at the equivalence point. We had 10 milliliters of the base, that would give us a 0.09 molar solution of our base. So hopefully this clears things up a little bit for you.